All right, good morning. So welcome back to Calc 2. Today we are going to do multiple integrals. So that sounds scary, and it is, but at least the first little bit of it is a gentle introduction. Okay, and we don't get to the really fun stuff in this class, so that's okay. So this is kind of a tour through double integration. All right, so I'm going to go ahead and share the screen, and we'll get started. All right. So look here. We have the integral, okay, of 0, 3 of x squared y plus 6y dx. Nope, 6y, not dy, just 6y. Okay, now normally, and I will continue, if we have a single variable sort of a function, right, just have a y equals f of x, right, or you've decided to let, let u equal some function of x, so now we have y of g of f of x, so f of x is equal to u, and you've tried to integrate that, and you still have x's in your, after you substituted, you still have x's in your integrand. Yes, I will still yell at you for that. You're not allowed to do that. Okay. So, if you've got a, x e to the x, x to the 2x, you said let u equal to x, du equals, d or 2, and you want to integrate this, I will still get mad at you for doing this because x is u is dependent on x, and you have not changed everything out. Okay, so you can't just go off and do this. All right. Whereas here we have two independent variables. We have an x independent variable and a y independent variable, and now it's different. Okay, so very much like with partial differentiation, we hold the y to be constant while we integrate with respect to x. Okay, so that's what's going on here. Okay, so what we're going to do is we're just going to integrate with respect to x. So that's going to be x cubed over 3 times a constant, okay, plus 6xy, because the 6y was a constant. So if we integrated like 3, right, the integral would be 3x. So if we're going to integrate 6y, the integral is 6yx. And you could write that any way you please. Because this is a definite integral, we will not need to put a plus c. Okay. So if we evaluate at x equals 3, we're going to have 27 over 3y plus 6 times 3y, and minus, okay, and this is 0 cubed over 3y plus 6, 0 times y. Okay, this is x evaluated at 0, this is x evaluated at 3. What is 27 over 3? It's 9y plus 18y, okay, minus 0. So this whole thing, 9 and 18, 27y. Okay, and that's what they are looking to see. 7y. Okay. We use this a bit in probabilities. All right, now this one, and again, look, we have a dx and we're integrating. So we're integrating with respect to x. So here we have 3 and 8. We have e to the 2x plus 5y. Now, the first couple of times I do these, sometimes the first couple of dozen times I do them, I don't like this. Okay, this confuses me. So what I'm going to do is I'm going to use my principles of algebra, right? And we're going to change that, because if you have, right, an a to the s plus an a to the t, that is equal, times a to the t, that is equal to the a to the s plus t, isn't it? When the bases are the same, right, multiplying, when bases are the same, we can add the exponents. Well, this formula goes in reverse too. So we could say this is e to the 2x times e to the 5y dx. Now, this 5y, that's a constant. Okay, we are as far as x is concerned, we are treating this as a constant. What can we do with constants in an integral sign? They can float out. Okay, again, normally, if you are integrating with respect to a variable, you cannot float it through the integral sign. That doesn't work. So it has to be a constant that you float through the integral sign, not an x. Okay, if there's a dy here, it couldn't do it. Right? So we're going to go ahead and say this is e to the 5y from 3 to 8 of e to the 2x. Now, if it's been a while since you've integrated, that's okay. Right? Let u is equal to 2x, du is equal to 2 dx. So dx is equal to, there's a dx here, dx is equal to du over 2. Okay. So going back over here, we're going to say this is e to the 5y integral. Now, I'm going to wait on my limits for just a moment. We have e to the u, because we're substituting, and dx is really, right, du rather, over 2. Okay. Now what we're also going to do is say when x equals 3, u is equal to 2 times 3 equals 6. Where did I get the 2 times 3? Right here. Okay. When x equals 8, u is equal to 2 times 8, 16. I'm going to pause. Resuming. All right. So let's go ahead and fix this. So this is going to be 6 to 16 instead, right? 6 to 16. Okay. So this is going to be 1/2, it's this 2 right here, e to the 5y, that's this business, integral 6 to the 16, e to the u du. Now this spares me having to go back and change things, okay? So we're going to have 1/2 e to the y, and what's the integral of e to the u? Just want to ever ask you. All right, so this is 1/2, 5y, e to the 5y, and then here we have e to the 16th, that's a huge number by the way, minus e to the 6th. There's really not a whole lot we could do with this. I mean, there's a couple of things we could do, but I don't think there's anything we really want to do with that. Why don't we just leave that there for the best? Okay, how do they want their answer? All right, they didn't say anything. So I'm just going to type this in. I'm going to say this is 1/2, it's 1/2 e to the 5y times e to the 16 minus, oops, not that minus, that minus e to the 6, oops, to the 6. All right, oops, not that parentheses, I meant that one. Right, and we should be all good there. Right, excellent. So only 13 questions on this one. It's not too bad. Okay, hopefully we won't get into something too terrible. Okay, now this one, so we've gone through the marginal ones. Okay, that's in probability. A lot of times, though, when you integrate out to one variable, they call it a marginal probability. So we have this thing. We have a 1 to 7 and a 0 to 3. We have an x squared y plus 9y dx dy. Okay. Now, this is called an iterated integral. Okay. And the way we read this, the way we interpret this, is that this business here is for the x variable. Okay. And this business out here is for the y variable. Okay. So if we're going to swap the dx and the dy, we have to swap these two. Okay. Now, dx, dy, okay, often we will abbreviate this as a dA. Okay, it's an area. But a dx is like a short little piece like that. Right, there's my dx, and my dy is a short little piece like this. When I multiply them together, we get a little square, dx, dy. That's not always the case. Okay, sometimes we're going to be told like we have to integrate with respect to two things, and we're not going to get this dx dy. We're going to get something weird like this, okay, or worse. Okay, so we have different functions for this, and then you can't just change the order. If you have to change the order, you have to do something with these guys up here. Okay, you have to replace what's happening. I don't think our class goes into doing that. So I think we're safe with iterated integrals for almost all of them. Okay. And if you took Calc 3 for proper, there'll be all sorts of fun things you'll have with something like this, and then right, and you could get DRs here, okay, but this is going to require trigonometry. We're not messing with that. So most of the time in our class, we're going to be dealing with this. At worst, we're going to be dealing with something like this, or I tried to draw a little curve like that in there. Okay, but most of the here's your spot. And if your DA really is something where your things are dependent on two constants, you're integrating over a rectangular area effectively, and it doesn't matter. Length times width is going to be the same as width times length. You can swap the order as long as you swap this order with this thing. You're going to swap them, right? This would be equivalent to changing the order and then going through it from that way. Okay, this was a 0. All right. So let's go ahead and have a look at what this is going to be. Okay, I'm not going to swap the order on this one. Let's keep it easy. Okay. So let's integrate x squared y plus 9y with respect to x. Okay. So we're going to hold our 1 to 7 out here. Okay. We're going to integrate from 0 to 3. X squared y plus 9y. We're going to have our dx here. You can put little brackets if that helps you group them, and dy. Okay. So we have x cubed over 3 times y plus 9xy. We're going to go from 0 to 3. Okay, and then we have we didn't really need this, dy. We still have an integral left over, so we're not done yet. Okay, so let's go ahead and tackle what this is. This is going to be 27 over 3y minus 3. That was 9. 9 times 3. Okay. 9 times 3 times y. Okay. This is x evaluated at 3 minus 0 over 3 y plus 9 times 0 y. This was x evaluated at 0. We still have to integrate this thing out. We still have to go from 1 to 7 with respect to y. So we're halfway through about 27 over 3, that's 9. So we have 9y plus 27y. This is all 0. Okay. So all of that is 0. And then we have a dy here. And we integrate from 1 to 7. Okay. We can actually add these up, right? 27 and 9, that makes what? We can have, this is 36y, 1 to 7 dy. Okay, so if you can combine terms like that, you should probably do so. Okay, so this is equal to 36y squared over 2 from 1 to 7. So this is 18y squared. Okay, from 1 to 7. All right. So we have 18 times 7 squared minus 18 times 1 squared. Okay. Seems delightful. So we have 18 times 7 squared minus 18 times 1 squared. Okay. And we end up with 864. Okay. What we did was we had this this value, okay, x squared y plus 9y squared. Okay, so we'll just draw our calculus manifold there. And you could look under the thing here, and here's my dx's, dy's, and then here's my area over above it. Okay, pretend all these line up. Okay. But that's what we're doing. So we're figuring out the volume of something under this sheet, under this curve. Okay, that's what's going on geometrically. What was that, 864? 864. All right. All right. All fun. So even though the function may not be quite so straightforward, that's okay. Look what we're integrating over. We're integrating over two constants. It's an iterated integral. So we don't have to worry about changing orders or anything like that. You can do it how you please. Okay, so this is 2 to 6. This is 3 to 7. We have x over y plus y over 9. Okay. They don't even care for us to do that. Okay, it's dx, dy. So remember that, the dx, dy bit, right? So this part fits with our x's, okay? And this part fits with our y's. So let's try something, okay? I don't know if the later parts of the homework are going to have us do this, but let's go ahead and change it. So let's go ahead and change this from 3 to 7, 2 to 6, okay? And we'll still have x over y plus y over 9. Now, because this 2 and this 6 is the range of y, we have to change the dy, okay? And then we'll have our dx later, okay? 7 to 3 rather, that was our dx. 2 to 6, that was our dy, okay? So let's integrate with respect to y here. So remember, x's are constants. So what's the integral of 1 over y? Right, so this is x ln y, right? Plus, and then we have y squared over 2 times a constant, 1/9, okay? And we're going from 2 to 6. Right? And then we still have our dx to match up with our 7 to 3. Okay, so here's our 3 to 7. Okay, we have our x, we have our ln of 6, right? Minus 6 squared over 2 times 1 over 9. This is x, this is y evaluated at 6. Minus, here's our 6 ln 2 minus 2 squared over 2 times 1 over 9. This is x, or y rather, y evaluated at 2. And then we have our dx out here, okay? Usually when you're doing these, I know there are faster ways to do almost everything that we do, which is fine. And if you get good at it and you want to do faster, that's quite all right. But my biggest issue with these is that I make arithmetic mistakes halfway through it. I'm trying real hard to make sure that that is not happening, okay? So to me, that is the thing that matters, is making sure I get the right answer as I'm going through this problem, okay? So what do we have here? We have x ln 6, okay, minus 36 over 6 squared is 18. So 18 over, 36, I'm sorry, this is 36. 2 times 9, right, this is 36 over 18. Isn't it 2? Okay, minus x ln 2 minus 2 squared over 2. Isn't that 4 over 2? That's 2. 2/9. Okay. And there was no x's in that part. Okay, so this is dx here. We still have to integrate for 3 to 7. Okay, so here's where we're going to pull some magic. We're going to say this is x ln 6 minus x ln 2. Okay, minus 2 minus a minus is plus 2/9. Okay, see, I should have left this as 18/9. Okay, and all of this is dx integrating 3 to 7. Let's pull an x out of here. we have x times ln 6 minus ln 2 minus, let's call this 18 ninths. So minus 18 ninths plus 2 ninths, because now we have common denominators, and we're going to add these. Dx integral 3 to 7. Okay, so this part here, this is going to be minus 16 ninths, right? Because negative 18 plus 2. All right, this is an x. Do you guys remember your rules of logarithms? Of course you do. Okay, so this is ln, right, of 6 over 2 is equal to ln of 6 minus ln of 2. Okay, so this is really ln of 3. So let's check. Okay, so we're going to say we have ln of 3. All right, look at that number. And then we're going to have ln of 6 minus ln of 2. Hey, would you look at that? They line up exactly. That's a property. Okay, you're allowed to do that. So this is 6 ln 3. Okay, we still have our dx. We still have our root 3 to 7. And now we have to integrate with respect to x. So this is going to be x squared over 2 times a constant. Okay, minus a constant, integrating 16 over 9 x's. And we're going from 3 to 7. Okay. So this one is not really a whole lot we could do. We can just evaluate at x equals 7. So this is going to be 1/2 7 squared ln 3. I'm sure that's a delightful number. Minus 7 times 16 over 9. Minus eval x equals 3. So here we have 3 squared, that's 9. So we have 1/2 times 9. Since I did it that way, I'm going to go ahead and change this 7 squared to a 49. Okay. This is ln 3 minus 16 over 9 times 3. So now there's some arithmetic. Okay, so here we have 49 halves ln 3, okay, minus 9 halves ln 3. There's not an ln in here. That's why I don't really want to divide them. Okay, there's still something we can do. I don't want to do it. Okay, minus 7 times 16. What is that? 42 or 70. So 16 is 10 plus 6. So 70, 7 times 10. And then 6 is 42. So that's what, 112. So this is 112 over 9 minus 16 times 3. That's 48. 48 over 9. But minus a minus makes a plus. Okay, so we have minus this one plus that one. Okay. And now it's, if I type this in, it's going to tell me like, hey, you're simplifying, you could do. Okay. These have common denominators. So what I can do is take our ln 3 out. Right. We have 49 halves minus 9 halves. See, that doesn't look so bad anymore. Okay. And then 48, 112 minus 48. What is that going to give us? Right, so that's going to be 10. We have 12 minus 48. That's 12 minus 8, rather. That's 4. 10, right, minus 4 is 6. So this is just going to be minus, because the minus 1 was bigger, 64 ninths. I'm sure that's delightful. 49 minus 9, that's 40 over 2. ln 3 minus 64 ninths. We're not going to touch that because not really a lot I could do with it. So 40 over 2, I could do that one. Okay, and now I'm going to cross my fingers and hope that we did everything right. (20) natural log 3. minus, what do we have here? 64 ninths. 64 ninths. Okay. So this is the exact answer. They didn't say put it to so many decimal places. If they did, we just punch it in the calculator and be done with it. But usually they're going to want exact answers. Oh, really? Why don't we get to do it again? Okay, what did I mess up? So 2, 6, 3, 7, x over y plus y over 9. Okay, dx dy. So this is going to be x squared over 2 plus xy over 9. 3 to 7, 2 to 6 dy. Okay, so let's see what we have here. Oh, x squared over 2 times 1 over y is what I wanted. That's what I meant. Okay, so this is going to be 49 halves times 1 over y plus 7 y over 9 minus 3 squared, so that's 9 over 2 times 1 over y minus 3y over 9. Okay, and we're still integrating with respect to y, 2 and 6. So we have a dy here. Shouldn't really be an issue. So we have 49 over 2 times 1 over y plus 7y over 9 minus 9 halves times 1 over y minus a minus, so plus 3y over 9. Y, 2, and 6. All right. These are both 1 over y's, so 49 over 2 minus 9 is going to be 40 over 2 times 1 over y. 7 and 3 make 10, so we have 10y over 9. This is 20 times 1 over y plus 10 ninths y. dy, 2 to 6. Now, integrate with respect to y, we have 20 ln y plus 10 ninths times y squared. I bet that's why I messed up right there. All the way back up here, but that's what I screwed up. No, I guess I didn't. Okay, well, we'll see if we get the same thing or not. Okay, I will bet I made an arithmetic mistake somewhere in there. Okay, some of you will see it. Some of you see it already. Like, wait, you forgot. It's a 2 and a 6 here. Okay, so we have 20 ln 6 plus 5 over 9 times 6 squared. This is y evaluated at 6 minus 20 ln 2 plus 5 over 9 times 2 squared. This is y evaluated at 2, keeping track of everything. So we have 20 ln 6 plus 5 over 9 times 36 minus 20 ln 2 minus, oops, that is a plus, oh, that's where it is. I messed up the sign here. Okay. All this fancy arithmetic, all this fancy math, and I don't get to do that. Okay. 5 over 9, okay, times 4. Okay, so 20 ln 6 minus 20 ln 2. What's 36 times 5 is 36 times 5. It's 150 plus 30. Okay, 30 times plus 6 times 5. So that's going to be 150 plus 30. So we have 180 over 9 minus 20 over 9. I think that's it. I think I messed up my sign there. So this is 20 ln6 minus ln2 plus 160 over 9. Yep, that's where it is. Okay. 20 ln3 plus 160 over 9. Oh, 20 ln2, I like that. Ah, shit. Come here. Plus 160 over 9. 10. So yeah, I even did this. They didn't like that. We're gonna do a final check here just to see. I did get the minus incorrect there. Should have been a minus. Oh, what am I thinking? Of course, I wrote down the 3. I wrote in 2. All right, well, this will stand as a monument to careless mistakes. All right. Okay. So another way of doing this. Okay. X squared plus 3y squared dy by dx, so dy dx. And we're saying that a lot of times, right, dr, a lot of times I'll just say dA here, okay? And then it's up to you to decide. X squared plus 3y squared. Okay, we have -1 between x and 1. These do not have to be the same. Okay, rectangles and squares have the same area formula, so it doesn't matter if your shadow of this sheet is like this or like this. You can still change the x's and the y's as you wish. Okay, you can do whichever one you want first. Okay, what do you want? Either of them looks like it's going to be an advantage one way or the other, so let's go ahead and do -1 to +1 of dx, and then -1 to +1 of dy. Okay, doesn't really matter. So we have -1 to 1. Remember, this is for y's. Okay, and then we're going to integrate. So this is going to be x cubed over 3 plus 3x squared times x. We're going from -1 to +1. Okay, and we have our dy still. Okay. So let's go ahead and figure this out. So this is going to be x evaluated at 1. Okay, so we have 1/3, right? X evaluated at 1 plus 3y squared of 1 minus -1/3, because x cubed, right? -1 cubed is equal to -1. Okay, minus 3x squared, right? Because we have a -1 here. Okay. All right. Oops, this is the plus. Plus. The minus for the -1 to +1. That's where this minus comes from. Everything else looks good. Okay. Now let's have a look. -1 to +1. We have 1/3 plus 3y squared minus a minus is a plus, so plus 1/3 minus a negative is a plus, so we have plus 3y squared. Okay. I fear I may be missing a minus, but not sure. Okay. So 2/3 integral y, 2/3 -1 to +1. And then we have 3 plus 3, so plus 6y squared. Okay. And dy. So this is going to be 2/3 y. Okay. Plus 6y cubed over 3. From -1 to +1. So this is 2/3 y plus 6/3 rather is 2 y cubed. We've already integrated. Okay, so y evaluated at 1, we have 2/3 times 1 plus 2, 1 cubed. This is y evaluated at 1 minus 2/3, negative 1 plus 2, negative 1 cubed. This is y evaluated at negative 1. Okay, so here we go. We have 2/3 plus 2. Negative of a negative is a positive, so plus 2/3. Negative, negative, so plus 2. And we end up with 4 plus 4/3. How do we want to say that? I'm going to say this is 12/3 plus 4/3. So we have 16/3. Okay, and again, I'm not making any promises. Okay, hooray, I could add. Okay, so that's mostly what we're dealing with here, is doing the arithmetic. Okay, let's see here. We have this guy here. Again, 3 to 5, 0 to 2. We have a region. Okay, so they could even tell us. Okay, so we have a region R, y, e to the x plus y squared, dx dy. We could really say dA here because it's really up to us on how we want to do this. 3x 5 and 0 to y to 2. Because we have an e in the thing here, I don't think this is going to help us. Okay, let's do y first. Okay, so this is 0 to 2, 3 to 5. Okay, and then I'm going to do the same thing we did before. Okay, so we're going to have y times e to the x times, right, because that's what this plus means, is it times on the bottom? That's e to the y squared. Okay, we went from dy and then dx. Right? So this x is a constant. We could slide this out of the y part of the integral. So this is 3 to 5 e to the x integral 0 to 2 y e to the y squared dy for this little part and dx for when we get the whole thing. All right. So let u is equal to y squared. Du is equal to 2y. Right? So dy. So y dy is equal to du over 2. Okay. So we're going to have 3 to 5 e to the x, 0 to 2. Well, y dy, right? Y dy, that's equal to du over 2, isn't it? And then this is e to the u. Okay. So integral, again, integral of e to the u, we'll say a u and a u. Okay. To make things constant, make things consistent. So this is 3 to 5 e to the x. Okay. E to the derivative. Oh, this is there should be a 1/2 here. Okay. This will float. This will float too because it's a constant. Okay. Integral of e to the u, simply e to the u for u of 0, u of 2, and then dx. Okay. So let's go back. So we've got 5 to 3, 1/2 e to the x. We have e to the y squared going from 0 to 2. Okay. And then times the dx. So we have to solve this arithmetic here. Okay. So this is 1/2, 3 to 5, e to the x. And now we have e to the 2 squared. 2 squared is what? 4 minus e to the 0. What's e to the 0? E to the 0 is 1. So this is e to the 4th minus 1. We have an e to the x here, 3, 5, 1/2. Can you type this in your calculator when you get an answer? Sure will. This is a constant. This whole thing floats through. So we have 1/2 e to the 4th minus 1. Okay, integral 3 to 5 e to the x dx. All right. So let's see here. We have 1/2 e to the 4th minus 1. Okay. We have e to the x from 3 to 5 because integral of e to the x is e to the x. Okay. So we have 1/2 e to the 4th minus 1. Okay. And then we're going to have e to the 5th minus e to the 3. All right. Really not a lot we could do with any of this. Okay. We could FOIL this out. Okay. I'm going to chance my luck and see whether or not we have to. Okay. So we have 1/2 e to the 4th minus 1, e to the 5th minus e to the 3. Okay. Now I'm just kind of hoping we don't have to do anything more. Okay, so this is 1/2 parentheses e to the 4th minus, oh, not that minus 1, e to the 5th, what's w, what the heck, e to the 5th minus e to the cubed. And again, we can't simplify that. I'm hoping they don't make us do it. It did make us do it, thank goodness. Otherwise, our next step would have been FOIL this out and then write that down. Okay. My first response to that would be no thank you, if I could help it. Okay. But yeah, we're not going to be that lucky. Or actually, we are that lucky. Find the volume under the given surface. Okay. This is a plane, right? This is a plane. So what we're going to do is we are going to figure out for this sheet. This is literally, right, a sheet. So remember, z equals, right, 6x plus 2y plus 7. This was equal to negative 6x minus 2y plus z equals 7. We could graph this, right? So here's my x, here's my y, here's a terrible z. And we could say, well, let z, y and z equal 0. So we have 6x equals 7. So x would be negative 7/6. So that would be down here somewhere. Okay. Let x and z equal 0. So we'd have negative 2y equals 7. Y equals negative 7/2. I want x to be negative 7/6. So that would be over here. Okay. Y is equal to negative 7/2. That's over here somewhere. Okay. Then we'd have z equals 7. So we'd be, let's get rid of this one. It's not where it is. Z would be up here somewhere at 7. And then we're kind of looking behind. Right, we're looking at it from behind. So this sheet like facing away from us, but what we want is this area that's in here. Okay, that's what we want, is that area. Okay. I should have done it like something like this, right? Can't really see too well, but all of this area in here, that's what we want. So it's like a pyramid type thing. All right, just to give you a geometric sort of what are we looking at here? But we have z is equal to 6x plus 2y plus 7. And what do we have? X goes from -1 to +1, and Y is going from 2 to 3. So X goes from -1 to 1, and Y goes from 2 to 3. Okay, and it's completely up to us. It doesn't matter which one you pick. Okay, it really doesn't. We're kind of screwed either way we're going to go here. Okay, so let's go 6x plus 2y plus 7. Let's go with dx. Okay, dy. So with the dx's, we're going from -1 to +1. From the y's, we're going from 2 to 3. Okay, so integrate with respect to x. So we have 6x squared over 2 plus 2y times x plus 7x. -1 to +1. We still have 2 to 3 of dy. Okay, so here we go. We have 2 to 3 of 3x squared, okay, plus 2xy plus 7x, -1 to +1. Okay, so here we go. Evaluated at x. They're evaluated x equals 1. So we have 3 times 1 squared plus 2 times 1 y plus 7 times 1 minus 3 times -1 squared plus 2 times -1 y plus 7 times -1. All right, dy. So evaluating, we've got 3 plus 2y plus 7 minus, okay, and we have 3 minus 2y, okay, and then we have negative times negative is positive, so we keep it positive. Oh, wait, let's put a -7 in here because we haven't done this one yet. Okay, so we have 3 plus 2y plus 7 minus 3 plus 2y plus 7, so we have 4y plus 14 here. Okay, so integrate 3 to 7, okay, of 4y plus 14, okay, dy. So this is going to be 2y, well, 4y squared over 2. 4y squared over 2 plus 14y. Okay. So we're not going from 3 to 7. We're going from 2 to 3. What am I doing? We're going from 2 to 3. Okay, so this is 2y squared plus 14y from 2 to 3. So we have y evaluated at 3. So we have 3 squared plus 14 times 3 minus y evaluated at 2. We have 2 times 2 squared plus 14 times 2. 3 squared is 9. 9 times 2 is 18. Okay, 14 times 3, that is going to be 42. Minus 2 squared is 4. 4 times 2 is 8. And 14 times 2 is 28. Okay. Okay. 10, right? 18 minus 8. What is 42 minus 28? So 14 and 28 makes 42. So 14 minus 20 or 42. I should have just done this. I confused the issue. It's 14. Okay, plus is equal to 24. Okay. Again, you can see my hardest spot is like following through the arithmetic. So I'm not making any kind of promises on how good of a work we do here. All right. Let's see. I think that's the end for this section, and we'll go through and do some more. Perfect. We'll stop. We'll start here again. Okay. So question 9. All right. So practice these, be good, and we'll see you in the next video.